Hi, this is Alec Dalton, signing in for the next interactive assignment for Instant Ice. So I'm going to try to replicate the 3 examples from the video that we had to just kind of show how this is done. I have we're in the freezer for a while, so we'll see how it goes. So this is one we practiced with actually. This one is liquid. Kind of see there at the top maybe that it's still sloshing around, so just back here on top. And okay, so I'm trying to tilt this up. Don't know if it's going to show, but you can kind of see right in this area where the ice has kind of frozen some bubbles inside of it. So it did solidify in there a decent amount. Some of it's still liquid, but there's ice in the middle of it where it's hardened. So we'll set that one aside. I have the bowl of ice in the video, so let's grab another water bottle. So in theory, looks like that one actually is iced over a little bit, but if you pour the water on here, so it doesn't look like that one worked like it was supposed to, but typically what's been happening with these experiments is the water in the water bottles, as they get cooler, the particles start to slow down. So when phases from a liquid to a solid, the particles are getting very, very slow. They're releasing some of the heat that occurs, and then the reason why, like in the videos we had and in these experiments, the reason why it looks like a liquid at first is because even though the water has passed its freezing point, it still is not quite solidified, and so what we're trying to do is we're trying to make the reaction take place to where the phase change actually occurs. So this experiment did not work like the video. The first one did. The other one that we'll do is I'm going to fill this with the ice water. So we'll get another bottle. We fill this glass up here. So we can set that again. I'm going to just steal one of these ice cubes over here. So in theory, putting the ice cube in the water that is below freezing point would cause it to freeze. Sorry, just giving it a little bit of time here. So it doesn't look like well, you can kind of see underneath. It's starting to form. It's not quite taking to the entire glass, but on the inside the ice is accumulating some of the other particles that are below freezing point. And actually at the top of the glass I'm starting to see some of the formations of the solid. Again, and this is because as the particles have slowed down, they're trying to form a crystallized structure. And since we're giving it a solid to cling to, it is drawing closer to that. So if I were to pull this out, it looks like a slushy almost, but it's also, since it hasn't fully reached that point, it has kind of these offshoots of solid ice particles to them. So again, going back to what the reaction is, the ice, because the water hasn't reached that solid point yet in all the water bottles, it is past the freezing point, but it's not quite there to where the phase changes occur. So what we have to help it do is have something called nucleation, I believe is how you say it, but essentially it's the idea that By giving some sort of a force to it, it will cause the change to occur to where those small particles that are already clumping together will then get a jolt to further combine with other ones. So it's why when you put the ice cube in the water, it starts to draw in some of those other particles that are already freezing. Now, so it looked like we were 2 for 3 on the experiments, which is okay. The reason why the ice bowl experiment did not work, my guess would be probably that the water, really in all of these examples, maybe the water was not as far past the freezing point, or maybe some of the water was at that point, but not the entire amount. So that's probably why the freezing point did not take place, to where it all started bubbling up, making the slushy example that was in the video. So that is the last interactive assignment. Thank you for your time. I appreciate it.